The next few videos are going to be a brief introduction to object-oriented programming, and we've already been using some of the conventions of object-oriented programming throughout this class. And I mean, you could take a whole theoretical year-long course on object-oriented programming, but this is just meant to be a quick introduction. And first thing I want to do is just show some examples of where we've already seen object-oriented programming. So one example, and maybe the first one that comes to my mind, is let's say, let's import matplotlib.pyplot as PLT. And here is the non-object-oriented way to plot something. I could say plt.plot, and then let's plot 3141. And before I show before I say what makes this not object-oriented, let me show the object-oriented variation of this. So I'm going to say big X equals plt.subplots, and then I'm going to say x.plot 3141. So they look quite similar. And certainly this functional version of it, certainly that is shorter. So if you just want to make a quick plot, I guess this one is probably better. But once you start wanting to do more advanced things in matplotlib, you'll be happier if you're using the object-oriented method. So what is the difference between these? I mean, they look very similar. I would say the difference is that this one is using the plot function from pyplot. So if we check, for example, help plt.plot, then here, for example, it says help on the function plot in this module. And then we see the plot help down here. Whereas if we do help x.plot, so here, instead of being called a function, it's being called a method. And I'd say the important thing is this thing here. It's the plot method of an axes subplot instance. So for example, if we're to check what is the type of x, we get this exact same word, axes subplot. And instance, that is the word that's used when like an object of that type has been created. It's called an instance of axes subplot. So to summarize this plot, plt.plot was a function, whereas this x.plot was a method that was attached to an axes subplot object. So this axes subplot, that is the object when we're talking about object-oriented programming in this case. Another example is we could say import NumPy as np, and then we can say rng equals np.random.default rng. And these parentheses here, that is instantiating. Okay, it's making an instance of a default random number generator. If we check what's the type of this RNG, okay, this is some object. It's a generator object. And then we have all these different methods for producing random numbers as their methods on this RNG object. So I can do rng.random, then 5, for example, and this gives me 5 uniformly distributed random real numbers between 0 and 1. And if we were to check help rng.random, okay, then we get random method of this NumPy generator instance. And so the reason I like this RNG example is because if you asked me to predict how are you going to make random numbers in a programming language, I would think, okay, there's just going to be some function. Function takes as input a number like 5, and then as output returns whatever, in this case, a NumPy array with 5 numbers in it. But that's kind of the right way to think about it. But in Python, in NumPy, the way you're supposed to create random numbers is not by calling a standalone function, but instead by calling a method on this RNG object here, on this generator object. So those are 2 examples we've seen in class of using the object-oriented way of doing things. This ax.plot, in that case, the ax was the object, or this RNG.random. In this case, the generator, this RNG, was the object. Okay, we will see an example of how using the object-oriented approach, how that can really simplify things in the next video.